Okay, see. So in the previous class, in the previous two classes basically, we have discussed about the building of the process dynamics, why this subject is important, what is the importance, what is the application of this subject, right? So in order to that, we have seen here the block diagram of the control system using this. Okay, we already have gone through this example. Now you can see there are two types of control system shown here. Okay, you can see here this is one of the blending process. This is the blending process, and I already told you what is the blending process. In the blending process, there are two liquid or two fluid or two mixture are going to be mixed. Okay, are going to be mixed. So let's say the first liquor is coming from this side with concentration x1 having the flow rate w1, and from the second side the concentration is, let us consider x2, and the flow rate of the liquor is w2. Both the liquor is coming inside the liquor are coming inside the tank, and from this stirrer the mixture the liquor are going to be mixed. So you can say it is just like example of dye, है ना? Dyeing of the any clothes, right? Or you can say the mixing of water in the, or you can say the milk in the water, है ना? So you can see there are two types of the configuration or control system are arranged shown here. Okay, so you can see here first how these are going to control. So you have to control, you have to choose first, you have to choose the, you know, uh, or what is the output. The output are is going to take your, let's say, the concentration x, and the flow rate should be the w. Okay, you need the whatever the mixture is coming from the as a product, that should be the concentration of x, and the flow rate should be the w, right? So you have to control the concentration. Ultimately you have to control the concentration, right? So how they are going to control? So for that purpose, first we have installed, first we have measured the concentration inside the tank, that is the mixture of this product. Okay, so the concentration is measured using the composition analyzer, right? 80, it is represented as a 80 in the diagram. This diagram I will also show you after some time, the piping diagram of the instrumentation diagram, right? So this is the composition analyzer. It is represented by the in the circle 80, and its role is to act as a sensor or transducer, you can say, since it measures the concentration and convert the signal into electrical. This is the electrical signal you can see here, and then one controller is there, right? One controller is there, and you have to set point is also there, just to take the minus. Okay, uh, set point minus measured value, it generates some error, and based on that error the composition controller sent signal to the control valve, and ultimately the flow rate of this, and fluid is going to be controlled. Any doubt? Any doubt in this problem? Anyone?
Mhm.
Yes or no? Say loudly.
Mhm.
No, sir.
No, sir. In the second problem, you can see how this is the different from the first one. How this is
S-
different from the first one.
So feed forward.
Feed forward. It is
Yes, sir.
the feedback. It is the feedback system. However, this is the feed forward system. Feed forward system. So whatever the disturbance coming inside the system, this is the disturbance, because we are the measuring variable is this one for the circuit or this process. This is a disturbance only. Now in the feed forward control, in the second types of the arrangement, we are not bothered, or we are not going to control the product side. We are not measuring the output, the concentration of the product. What we are going to do in the second side, in this picture or in this process, we just measured the the disturbance, whatever it is coming in the system. तो सिस्टम में आने से पहले ही हमने इसको मेजर कर लिया. We have a set point, just calculate the error. After that error, that signal is sent to the control valve, and based on that, the second flow should be the concentration should be controlled, right? कितना होना चाहिए? So basically, in most of the system, the feed forward control and feedback system are not using separately. Feed forward control is generally used with the feedback system. Okay. So we will see in the advanced process control when we will discuss these things in the more detail. So here my motto is only to show you that there are different type of the controls mechanism may be present there. ठीक है, फीडबैक सिस्टम ही केवल नहीं है, फीडबैक सिस्टम के अलावा फीड फॉरवर्ड कंट्रोल भी होता है. ओके, नाउ नेक्स्ट पार्ट. नाउ टाइम टू थिंक. Why I am saying time to think? As a control engineer in the process industry, let's say कि आप मान लें कि आप खुद एक ऑपरेटर हैं प्रोसेस कंट्रोल इंडस्ट्री में, और आपको ये टास्क दिया गया है. अपने आप को रखिए जरा एज ए ऑपरेटर इन फॉर द सम टाइम फॉर दिस एग्जांपल. ओके, एंड महसूस करो कि आपको क्या करना है. ठीक है. सो द प्रॉब्लम इज, लेट्स सी, the problem is feel the problem. It is very, very important, right? So the process is running along at a steady state. ये कोई प्रोसेस है जहाँ पे स्टीम वन, द कंसंट्रेशन ऑफ द स्टीम वन इज 1 g per L, and the velocity is 10 liter per minute, is coming from this side, and the second stream is coming from this side with the concentration 4 g per L. L is the liter and G is the gram obviously, and V2 is the 20 L per minute. That is the volumetric flow rate. V1 and V2 is, what is that? That the volumetric flow rate means uh, the meter cube per second or per time. Okay, meter cube means the volume, whatever the volume is flowing with the time. So this is the volumetric flow rate. Okay, next see. So this process is running at the steady state. बहुत टाइम से ये ऐसा ही चलता आ रहा था, जहाँ पर CA1 ये था, B1 ये था, CA2 ये था, V2 ये था. तो mixing T है, this is the T, this is the, you can say T, and at the T it just added, and 30 liter per minute is going inside the tank, right? The volume of the tank is a 150 liter, and the heater is already running. Okay, but we don't know what is the concentration G per L. Okay, and this situation is running from the long time. Okay, now come. The concentration of A in the stream is 1 G per L, and the stream 2 is G per L. So, already mentioned. Okay? The problem is starting from here. At 3 p.m. 3 बजे क्या होता है? The shift changes at the plant. Okay? The 3 p.m. before you, one of the operator was there. Now the shift changes, and you as an operator, है ना, are placed in that process for the monitoring, right? And at that time, the new operator, or as a process engineer, you misread the unit of the flow meter, right? You as a process engineer just misread that flow of that process and switches the flow rate of the two stream. Switches the flow rate of the two stream just to switch the flow rate. Means what you have done, you 20 को आपने 20 लीटर पर मिनट कर दिया और 20 को आपने 10 लीटर पर मिनट कर दिया. Concentration you have not changed, but only you have changed the volumetric flow rate switches. Okay, it means you have switched the stream 1 to 20 liter per minute and stream 2 at the 20 liter per minute, what I have told. Okay, अब होता क्या है, 330 पर let's say the shift supervisor, it was done by the operator. It was done by the operator. After half an hour, the supervisor, okay, the boss of the operator, you can say, the shift supervisor after half an hour at 3:30 p.m. comes and see the situation, and he was hurries to the control room to determine the source of the problem. But उसको पता ही नहीं है कि क्या हुआ, जस्ट वो देख रहा है, तो उसको पता नहीं, वो अपने कमरे में और कंट्रोल रूम में देख रहा है, तो उसको नहीं पता चल रहा है कि व्हाट इज द प्रॉब्लम, व्हाट इज द सोर्स ऑफ द प्रॉब्लम. नाउ बीइंग एक्सपीरियंस विद रिएक्टर, now being experiencing with the reactor. Okay, so as a supervisor, use your knowledge to determine what was happened to the exit concentration. Exit concentration के साथ क्या हुआ, यहाँ पर क्या हुआ, from heating vessel over first half hour of the shift. आधे घंटे के उस ड्यूरेशन में क्या हुआ. राइट, प्रॉब्लम समझ में आया, यस और नो? फर्स्ट ऑफ ऑल टेल मी द प्रॉब्लम इज क्लियर और नॉट?
Yes, sir.
Okay, I will ask. As such type of problem will come. This is the case study, right? So it may be such type of problem will come in the exam. Okay. So okay. So for that purpose, you have to understand how the process is running. Okay. How the process is behaving. What is the behavior of the process? You have to understand first. So for that purpose, what you have to do? You have to मॉडल द मिक्सिंग टी एंड द ब्लेंडिंग टी. आपको क्या करना है, मिक्सिंग टी एक प्रोसेस यहां पर है, दूसरा प्रोसेस यहां पर है, इन दोनों को आपको समझना होगा पहले, यूजिंग द अनस्टेडी स्टेट मास बैलेंस इक्वेशन. मास बैलेंस, एक्चुअली मास बैलेंस इक्वेशन वी हैव, आपको मैंने पहले बताया था कि फिजिकल कुछ रूल है, कुछ लॉ है, एंड बेस्ड ऑन दैट फिजिकल लॉ वी आर गोइंग टू ड्राइव द मैथमेटिकल मॉडल. We are going to drive the mathematical model for the system. Mathematical model for the system. And based on that mathematical model, we will try to find the transfer function after this. Okay. First, we have to develop the model, mathematical model, and what is the and how this mathematical model is going to develop based on the physical law or the data history The data scientist may develop the model, है ना? Based on that model, we can predict the behavior or future of that process. Okay. So first principle, that is the physical law, that is the conservation of mass, energy, momentum, and all these things. Right? इस तरीके से होता है. अच्छा, तो हमें अब क्या करना है, इसको समझते हैं. So we are going to write the unsteady state mass equation. Why it is mass equation? Because some mass is coming from this side, some mass is coming from this side. At the junction, it is just added. तो यही हमें करना है. तो हो क्या रहा है? To predict the behavior of the process since shift change and unfortunate error by the new input. We have to calculate also the error. So what we have to do? A balance on component A around mixing T before and after change. Before 330 or after duration of 3 to 330, what will happen? We have to check. तो हमने क्या लिखा, देखिए जरा. Whatever the component is coming from the first A side, rate of A into mixing T in stream 1 plus rate of A into mixing T in stream 2 is equal to rate of A from this side plus this side is equal to this side. Yes or no? Yes or no?
Yes,
Whatever
sir.
the rate
Yes,
of
sir.
the concentration will come from this side is equals to plus this side is equals to the third side. Okay, so based on this we have calculated the rate. Okay, so this is the volumetric flow rate and this is the concentration of the first, we just multiplied. Okay, we have calculated this rate of A and second rate of second stream 2, okay, is equals to the third, right? V1, V2, V3, CA, C1, C2 is already given. Based on that, you can calculate the CA3. Am I right? Any problem? You can calculate CA3. That is the equals to the 3 gram per liter. 3 gram per liter. राइट 3 ग्राम पर लीटर में हमारा इधर से 1 ग्राम पर लीटर जा रहा है, इधर से 4 ग्राम पर लीटर जा रहा है, तो अल्टीमेटली इसके अंदर किस कंसंट्रेशन के साथ जा रहा है बेटा? 3 ग्राम पर लीटर. ओके, नाउ ये तो हो गई बात बिफोर चेंजिंग, बिना स्विचिंग के समय आपने जब 10 और 20 लिया था. नाउ यू हैव स्विच द फ्लो रेट. 10 को आपने 20 कर दिया और 20 को 10 कर दिया. देन क्या बना तब देखते हैं हम लोग. After the change, the new feed concentration to the heating vessel is 20. ठीक है, V1 CA1 V2 CA2 is equals to V3 CA3. Based on that, you can calculate the CA3. The V1 now becomes 20, V2 becomes now 10. It is switched. Okay. So based on that, you can say the concentration becomes CA3 is equals to 2 gram per liter. So ultimately, the concentration what you have desired is decreasing. Yes or no? Yes or no?
Yes, sir.
Yes, sir. Yes.
It means so the net result of the operator error is, उसको ये समझ में तो आ गया है कि हुआ क्या है कि decrease the feed concentration, we have just decreases the feed concentration to the heating vessel from 3 to 2 gm. इतना मैंने कर दिया है, इतना उसको समझ में आ गया प्रॉब्लम. यस और नो? अच्छा, अब प्रॉब्लम है कि उसको इंस्टेंट उसको ठीक भी करना है. तो आफ्टर एनालाइजिंग प्रोसेस फॉर मोमेंट इट इज अपरेंट दैट द एग्जिट कंसंट्रेशन, अब हमें चेक करना है कि एग्जिट कंसंट्रेशन जो है वो कैसे चेंज हो रहा है. यहाँ पर एग्जिट कंसंट्रेशन यहाँ कैसे चेंज होगा. ओके, वी विल सी. बट द इनपुट इज चेंजिंग फ्रॉम ओके 3 to 2, 3 gram per liter to 2 gram per liter. This is the C. Yes or no? Yes or no? Okay.
Yes, sir.
So you can see here. So if the process is left in the current configuration for a long enough time, so what is the situation? ऐसा होगा तो क्या होगा? इसका मतलब है concentration when you have changed from 3 to 2 gram per liter at 3 PM आपने ऐसा कर दिया. ठीक है, तो अब देखना ये है कि ये 3 to 2 ग्राम पर लीटर क्या तुरंत हो जाएगा? 3 बजे आपने स्विच ऑफ आपने चेंज किया है, क्या ये तुरंत हो जाएगा? 3 ग्राम पर लीटर टू 2 ग्राम पर लीटर तुरंत हो जाएगा? किसी में कुछ ट्रांजिशन आएगा? यस और नो? सम ट्रांजिशन विल कम ना?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so what is that transition period? Okay, and how that transient behavior is going to change? Okay, so आप देख रहे हैं कि 3 ग्राम पर लीटर से 2 ग्राम पर लीटर तो होगा, बट द बिहेवियर विल चेंज, है ना? तो इसको आपको चेक करना है. ओके, ठीक है. सो आप V3 को आप यू कैन कैलकुलेट V3. हाउ द V3 बी कैलकुलेटेड? बिफोर चेंजिंग 10 plus 20 or after changing also the 10 plus 20 plus 10, right? So the volumetric flow rate is not going to change, so it will come 30 liter per minute. Okay, now अब हमें क्या है, ट्रांजिएंट जब भी आपको कैलकुलेट करना तो whenever you set the transient it means you have to write the equation on steady state. yes or no? मैंने आपको
Yes,
बताया
sir.
डायनेमिक इक्वेशन you have to write the dynamic equation और how the dynamic equation will come in the picture. इसको आप समझिए. अगर आप इसको समझ गए, 2-4 प्रॉब्लम अभी है, शुरुआत का प्रॉब्लम को समझ गए, it means you are able to develop the mathematical model. Otherwise there is no method to teach you, to learn you how the mathematical model of the system is going to develop. So first 4 to first 5 example will help you how the model is going to develop, right? So try to understand 1 to 5 problem. Then, if you have any problem, you can discuss me. तो समझते हैं. Now we are going to write the dynamic equation. अब कैसे डायनेमिक इक्वेशन लिखा जाएगा भाई? तो rate of A into the heating vessel, rate of A into the, ये A मान लेते हैं कुछ देर के लिए, यहां से इन हो रहा है, इन माइनस आउट. मान लो कुछ देर के लिए कि कोई एक सिस्टम है, एक टैंक है, इन हो रहा है साहब, कुछ फ्लो रेट आ रहा है क्यू नॉट फ्लो रेट से जा रहा है लेट से, और यहां पर लेट से एच, ये हमारा लेंथ एच. तो इन माइनस आउट, इन माइनस आउट, देखिएगा ध्यान समझिएगा. अगर हम मास में भी कहें तो इन होगा समथिंग, समथिंग आउट हो रहा है, और समथिंग यहाँ पे एक्यूमुलेट हो रहा है. या सुनो, एक्यूमुलेट हो रहा है यहाँ पे, कुछ यहाँ पर होल्ड अप हो रहा है. या सुनो, अरे बोलो
Yes,
भैया.
sir.
Yes, sir.
This means you can write that the input plus some hold is equals to out. Yes or no? Input,
Yes, sir.
whatever is coming from this side plus some this hold is equal to this side. Or you can say that this input minus output is equals to whatever this is going to hold. यही तो hold होगा. अगर आप बाल्टी किसी भी, suppose that you have hold, you have in any bucket, let's say you have done some hole from this side, okay, and you started the tap from this side. So okay, and this is going to first fill, right? And also at the same time the water is leaving from this hole. Yes or no? So what you can say, कैसे ये कैसे चेंज हो रहा है, what is the dynamic? So you can write the out minus in is equals to whatever the accumulation. Is it clear? Is it clear?
Yes, sir.
So you can write here the in minus out, rate of A into the heating vessel, minus rate of A leaving from the heating vessel is equals to whatever the accumulation accumulation of A heating in the A. ठीक है? So how it can be written? Simple. V3 into CA3, V3 into CA3 minus इसका जो आपका V3 into CA is equals to whatever the accumulation. And accumulation is written, always written in the form of the d by dt. Hold up. ये क्या हो रहा है? Change हो रहा है with the time. The level of, you can say the dH by dt, है ना? dH by dt. The height is changing. The concentration is changing with the time. Okay? The concentration is changing. The volumetric, the accumulation of A in this heating vessel is changing with the time. Okay? So you have to write the d by dt of the VCA. Is it clear or not?
Yes, sir.
Okay. So ultimately, when you solve this equation, this is the simple equation. Okay? Differential, first order differential equation. You can solve it after the dividing the V, whatever the some formulation is doing. तो यू कैन सी हेयर, अगर आप कोई फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन देखें, फर्स्ट ऑर्डर कंट्रोल सिस्टम को देखें, तो वो भी कुछ इसी तरीके का होता है, टाउ एस प्लस वन अपॉन टाउ एस प्लस वन. या सुनो, अगर इसको आप सॉल्व करेंगे इन द फॉर्म ऑफ डिफरेंशियल, यू कैन एक्सप्रेस लाइक दिस वन आल्सो. इज इट क्लियर? सो व्हेन यू सॉल्व, this is the either you can solve with the help of the Laplace transform, or it is a simple differential equation, first order differential equation. Just you can solve this one. Okay, you know the you know the initial value of Ca0 is equals to 3 gram per liter. It is the first order differential equation. Okay, V by V3, V is known, V3 is known. Okay, Ca3 is also so known, so you can calculate the Ca. Okay, right? S into 5 into S into Cs minus Ca0 plus Cas is equals to 2 by S, and you can calculate the Cs, or you can solve simply with the help of the integral. Okay, so after solving, just you got Ca is equals to 2 plus e to the power minus t by 5. 2 plus e to the power minus t by 5. इसका मतलब क्या हुआ कि 2 plus, अगर if the t is equals to 0, then what is the value? If the t is 0, then what is the value? What is the Ca? if that Ca, if the T is equals to 0, then what is the value? Ca is equals to, if the T is 0, then 2 plus e to the power minus 0 by 5, it is a 0. So it is 1 plus 2 is equals to 3. So you can see here at the time T is equals to 0, this is the starting point from the concentration is 3. As time is increasing, T is equals to 1, 2, 3, 4, 5. You can see here there is a decay in the concentration. It follows the exponential rule. This is the path. Okay. So this is the first part of the problem. This is the first part of the problem.